So what we're going to do on the second half of 1.5 is we're going to start changing things that are already in units. Like, for example, I'm going to put a number 12 right here in parentheses, and it's going to say 9 gallons per second. 9 gallons per second. And it's going to ask you to convert this into quarts per minute. If something has a break in it, 9 gallons per second, this is like how much water would escape if you had a broken pipe in your wall. 9 gallons per second, that's how much water will probably come out if somehow you were nailing this into the wall and there was a water pipe behind it and your nail went through the wall into the water pipe. Whew, that's how much water is coming out. 9 gallons per second. And somebody wants to know, well, how many quarts is that per minute? So what we're going to have to do is we're going to have to multiply by some conversion factors to get to quarts per minute. Notice that this is different and this is different. And we have to turn two different things. And the process is still the same as what we did before. This is why the fractions were so important. So what we're going to do is we're always going to multiply, and give yourself a lot of room when you make these parentheses. Make it nice and long because there's going to be numbers and there's going to be units that follow. Right now, the top is in gallons. I don't want the top to be in gallons. I want the top to be in quarts. My question to you, on your chart, is there something, because since this is in volume, is there something that goes gallons to quarts? Let's take a look. Do you have something in volume that goes from gallons to quarts? Right there. We have some numbers. But before I do the numbers, I always look for the units. If I want gallons to cancel, where does gallons have to go? If you said the bottom, you are correct. And do I know how many gallons? What unit am I going to convert it to? What is that equal to? And I'm going to use a Q and a T and an S for quarts. That'll shorten up quarts. Now, once I get the units, then I start putting in the numbers. Gallons and quarts. How many gallons? How many quarts? Now, I don't ever grab my calculator yet until I've checked the units. Let's check. Does gallons over gallons, does that reduce? Draw a line, draw a line. What this tells you is we are now in quarts per second. Quarts over seconds. Is that what I want to be in? What do I want to be in? Quarts per minute. So I have the top that I want, but I need to get rid of seconds. Where is the seconds? Where do I need to put the seconds to get them to cancel out? We're going to need another conversion factor. So nice big parentheses, because we're going to have numbers and units. Another fraction bar. I want to get rid of what? Okay, so what I want you to do is tell your neighbor, where are you going to put seconds over here, and tell them why. Very good. I heard lots of correct answers. It goes where? Tell me out loud.
Top.
Almost everybody said the top. Almost everybody said the top. There was only like one wrong answer. In order for it to cancel out, if it's on bottom, I need it to be on top so it can reduce to 1. Because seconds divided by seconds is equal to 1. It will reduce. And do I know how many seconds are in? What do I want to go to? Do I know something like that? Seconds per minute. How many seconds are in a minute? Let's do the numbers now.
60.
Are in how many minutes?
1.
Now let's see. Can I cancel way over here and way over here? Sure. You can do multiplication in any order. So I can go the first thing all the way to the last thing since it's all multiply. That's the best part about that commutative property of multiplication. Now let's check our units. I'm going to be in quarts per minute. Is that what I want to be in?
Yes.
If you're in the units you want, now you can go to your calculator. Now we can go to our calculator. And I break out the calculator. And 9. It's over 1, but I don't need to put over 1. Times. What do you want me to put? Do you want me to put 4 over 1 or do you want me to put times 4?
Times 4.
You're using your smarts. You're being smarter than, oh, I don't need to put that over 1 in the calculator. That's good. If you're not sure, then just put it in anyways. Calculator will figure it out for you. Times. What do you want me to put? And then my calculator says it's 2160 quarts a minute. Every minute, that's how many quarts are spewing out if you have 9 gallons per second. Wow. It's a lot. So, the next question that I had for myself is, Mr. Paramo, why are we doing this? Why? Because you can do this for something that makes sense in real life. Let me give you a real life example. I used Usain Bolt in my example, but I decided to change that. I'm going to go over to this green poster right here. And this green poster has the top 10 boys track and field mark ever. Our fastest kid ever on Buchanan's campus has run the 100 meters in 10.69 seconds. I wanted to see how fast it was. I remember that kid too.
That's not that fast.
Okay, this is not Usain Bolt fast. Usain Bolt ran in 9.8 something when he won.
9.82.
Somewhere in that neighborhood. But here's what this Chris kid did, who's our boys' fastest runner ever on Buchanan's campus. He ran 100 meters in 10.69 seconds. Got that? Now here's the deal. If I were to ask you, well, how fast is that? You would go, how do we measure speed? Most of you don't understand meters per second. Most of you understand something when you're in a car. When you're in a car, how fast do you go when you're on the freeway?
90.
Wow. Your mom drives fast. Or your dad drives fast.
My mom.
Okay, when you're driving down Teague, how fast are you driving?
20.
So what units are you using?
Miles per hour.
Okay? How many miles per hour is this?
I don't know.
Let's find out. Let's find out. Okay? This is in meters per second, right? Let's multiply by something. I want to find out how many MI, which stands for miles, M by itself stands for meters, just in case you didn't know. MI stands for miles per hour. I'm going to put that off to the side here. MI stands for miles. M stands for meters, just in case you need it. You can't see that, so let me scoot it over a little bit. MI stands for miles, and M stands for meters. I want to know how fast the miles per hour, how many miles per hour this is. So I need to get rid of meters, don't I? Let's get rid of meters. Fraction bar. Meters is going to go on bottom. Do I have meters to miles? Let's check.
No.
I have meters to feet. I have miles to kilometers. And I have miles to kilometers. I have two different conversions I could use. Okay. I'm going to have to convert from meters. Man, should I do meters to feet? Yeah, let's do. Do I have feet to miles? Yes, I do. Let's do meters to feet. Meters. One's on top, one's on bottom. And then I have meters and feet. And how many meters are in a foot or vice versa? Let's look at our piece of paper. What does our piece of paper say? 3.28 feet in every 1 meter. Now let's cancel something out. Meters goes away. What does that mean I'm in? Feet per second. Is that what I want to be in? Nope. Got to multiply by something else. Can I get rid of feet? Feet per, what's my goal to get into?
Miles.
I want to get, and I have that. I have feet in miles. So let's do feet and MI for miles. 1 mile is how many feet?
500.
5,000.
Or 500.
280 feet are in a mile. So what am I in now? Miles per second. Almost there. Another conversion factor. What do I want to get rid of? Where does it go? And I know how many seconds are in a minute. How many seconds are in a minute? 60 seconds are in 1 minute. If you don't have these time ones, because I did not put time on this chart, you can add the time ones on your chart if you need to. Okay? 60 seconds per minute. Seconds cancel. Even though they're really far apart, I can use that commutative property. Almost done. Now I'm in miles per minute. I'm almost there. I need one more conversion factor, don't I? And how many minutes? Because I need one on top, one on bottom. Minutes to what?
Hour.
How many minutes?
60.
How many hours?
1.
Let's cross off minutes, and then I'm in miles circled to hours, miles per hour. Now I have everything I need to know how fast did Chris Brusenbrack run in the 100 meters in miles per hour. I'm going to punch it in. You can't see that. Let me scoot it up a little bit. There you go. That looks better. Fraction button. 100 over 10.69 times. What do you want me to type in here? I don't have to put over 1. You can if you want to. Do I have to put the fraction button on the next one?
Yes.
Okay, so fraction 1 over 5280 times
60.
Okay, times.
60.
Now before I press equals, how many miles an hour does he run? Yes. What do you think? How many miles an hour is this kid running? And he runs 100 meters, fastest ever kid we've ever had on campus. And he ran a 10.69 100-meter dash. How fast is that in miles per hour? You think he's running as fast as somebody on the freeway?
Nah.
Think he's running as fast as somebody on a bicycle?
Yeah.
Maybe.
Going faster than somebody on a bicycle?
Yeah.
Think he's going as fast as a school zone, or is he going as fast as somebody down Herndon? What do you think?
School zone.
How much? Let's find out.
Oh.
Let's find out. Equals. How many miles per hour is he running?
I wish I could go fast. God blast.
By the way, in my other class, we figured out with Usain Bolt, the fastest man ever. We didn't do world record time. We did what he did in Rio, and he could run 22 miles an hour. So just so you know, the fastest human can probably go around 23 miles an hour. That's the most we can do without any aids, without anything that's going to make our body go faster, like a bicycle or a car or something along those lines. Now, let's flip our page over. Let's talk about unit rates. Unit rates are when your denominator that's supposed to be an A. Denominator is equal to 1. It's parts per unit. Let me give you an idea of what I'm talking about. Earlier, we talked about that kid's name, Chris, who ran the 100 meters in, how fast did he run it in? I forgot.
20.
10
69.
Yeah, 69 seconds. I could flip my paper over and I would know it. Oh, there it is. 10.69 seconds. That's their school record in the 100 meters on the boys' side. Now, if that's the fastest ever, is that a unit rate? Is this a unit rate? I'm going to put unit rate question mark because that's what your worksheet is going to ask you to do. Is this a unit rate? Your answer is no.
No.
Because that's not how fast he's running per second. Parts per unit. He's running 100 meters in 10.69 seconds. If I wanted to find out what his unit rate is, what I would do is take 100, delete, messed up, fraction button, 100, and then what I would do is divide it by 10.69, and then I could figure out as a decimal, he runs 9.35 meters per second. If I take this top number and I divide it by this bottom number, that's how many meters every second he is going when he's at full speed. I guess I could say when he at his average speed, not counting from the start where he's starting at 0 meters per second. Does that make sense to you? So, to find the unit rate, I'll move this up a little bit. To find the unit rate, because you'll be asked to find it, divide the top by the bottom. When I was a kid, my dad would say, go put $10, go up, because this was before they had these chips and debit cards you could put into the gas machine. You would go to a gas station and there wasn't that stuff around when I was a kid. And my dad would give me $10 and I was a little boy, so I would do what Dad said. Dad said, go to the gas station and tell him $10 on pump 3. And I would take this $10 and I would go over to pump to the guy and say, I need $10 on pump 3, right? I was a little kid. And I helped my dad out. And he would go and he'd pump whatever he could get for $10. That's what he would put in his tank. Sometimes he had more, sometimes he had less. But if he puts $10 in, let me write that down, $10, and he got 4 gallons of gas. It wouldn't actually be 4 gallons. It'd probably be like 4.657. They have some weird numbers when you're doing stuff like that. Is that the unit rate? No. If I asked you to find the unit rate, let's find it. $10 gave him 4 gallons of gas, and I'm making this up because way back then you'd actually get a whole lot more gallons for that amount of money. $10 divided by 4 gallons is, what is this? What is the 2.5 anyways? That is the price or the cost per what? Gallon. $2.50 per gallon. Back then, gasoline was like $1.80 or something back then, like $1.12 when I was a kid. So he would have had a lot more gas than that. And so keep in mind, what is a unit rate? A unit rate is how many parts per whole do we have.